I want to go over some of the maybe integrations that I have been trying to do with the ESP32. Basically, the idea here is that I wanted to send the notifications from something, uh, from some sensor, from the ESP32 broadcasted somehow somewhere, and I started using my phone for this. Um, so I want to go over the setup to get this setting working. So I'm using Iguana right now. I'm not very familiar with the editor itself. So let's see, exit presentation mode. So yeah, the editor that I'm using right now, I think it's called Iguana. It's the current editor that I was able to find on the internet. So just the default settings. I'm following a few tutorials around, like maybe not tutorials really, but the different examples that they have on GitHub. I'll post a link to it a little bit. So first, let's look at the Android manifest. To be able to communicate with the ESP32, what I found is that maybe I would use Bluetooth Low Energy and broadcast the information. So this is a little bit different than the usual Bluetooth. And for example, we can advertise that we can provide certain packets, but it doesn't necessarily behave like a normal Bluetooth device. I am only able to connect to one specific um, endpoint or pair with a specific device. I'm not sure yet if this is something I need to change on the side of Rust. So let's look over some of the settings that are needed for this. So I need to add permissions to be able to do a Bluetooth connection. Um, Also, we are needed to add this access find location. Apparently, when I am searching for devices, I may broadcast how close I am to these devices and so on. So I needed to add these two permissions that would allow me to actually scan devices, and the signal will show up on the other side and so on. I needed to create this foreground service because I am using some Bluetooth low energy definitions. Then I'm also asking to access the background location. In my use case, I have a TOF camera, and this TOF is measuring distances every so often. When a distance is very close, or actually it doesn't really matter how close it is, every now and then it is going to send information it's going to broadcast information. um, and in some cases when an object is too close, I want to actually make the phone vibrate. So I need to add this permission here. And also, if something is very close, I want to send a notification, because my use case is that I will be, for example, walking around the house. I would be carrying this time of field sensor, and I am blind on my left side. So if there is an object on my left side, then it should send a notification over BLE to my phone, and my phone is the one that vibrates. I'm working on another repo where I intend to make the devices work together, and they would be appearing and disappearing. So I will create a video about that soon. I think it's a project called Volvox, And the idea is that it will not be just the phone that vibrates, it will be different things. But yeah, the use case is that what vibrates is my phone, and I get a notification when something on my left is very close. And then there is different frequency of notification. For example, when something is very far, I don't want to notify too often. I don't really care too much. So once I will look at the logic in a little bit. And when something is closer, I want to notify more often. So basically, the phone is the ESP32 is always listening. And then depending on how close something is, it has a different tick frequency in which it says, an object is very close, so I'm going to notify right away. Or something is very far, I'm not going to notify. And something hasn't changed a range, so I'm also not going to change the tick ratio or something like that. So if I try to explain this a little bit, 1 second. So if I try to explain this a little bit, it would look kind of like this. We have distances, and within these distances, I think the limit for the current sensor, this is a BL53 L0X. The limit for this is 2 meters. So I have from 0 to 2 meters. And you start to see that maybe this is not sure if I can change the background to something more. Let's create a new file 1 second, because otherwise it is writing over the new scratch file. What is a scratch file? Can I just create an empty Java file? And then let's move this away. And let's see if I can move this a little bit like this, maybe. Anyway, though we have from 0 to 2 meters, the sensor is going to be constantly gathering data. So I guess it would look kind of like this. And I decided to create something that is like different ranges. And these different ranges would mean different notification intervals. So this will be closer or closest or very near. I think I created a few more because I also got another sensor for 4 meters. So I have to use a little bit different, but the idea is that there is closest or closer or dangerous, there is near, there is far. And then this specific one, when we get this much, we're going to say that we basically couldn't detect anything. So this is I think it's none or something like that. So this is the ESP, and it is constantly reading. And then when it is closest, it will say, I'm going to send a notification every second. And then the phone will get a notification that says, hey, every second we got this much distance, and so on. If something is not so close, then I was trying to go for an exponential backup of sorts, where you have 8 seconds and then something like this. So this works in two ways. The first one is that when we send a notification back to the application, to Android, when something appears in 1 second, then it is because it is something that is dangerously close. And so the sensor will come up and pick up the first time and says, oh, there's something very close. So imagine that the last time it was 16 seconds intervals because something is very far. It is constantly reading every second. So the notification period changes automatically to be 1 second because we want this to be something that is urgent. The user needs to be alerted that something is very close. So this notification is sent 1 second, and this is why we need the vibration. The vibration will then on the phone trigger, and then the notification would be sent, and we would say, "Hey, this sensor says that there is something that is very close." Um, if the object moves the next second that it is measured, then, or if we move and the object is farther, and imagine that it becomes 4 seconds, then it will not send a notification anymore. It will simply move into the 4 second interval, and every 4 seconds, then it will let us know if anything has changed. So the idea here is that the receiver, which in this case it is the phone, it would know that it has to be looking at expecting data this so often, and if it doesn't receive this data, then it also lost contact with the application. Sorry, with the ESP. Maybe the ESP went out of range, maybe it's turned off, or and so on. So yeah, this is the way that the logic works. So our goal here is that the esp32 transmits certain attributes with some IDs. And this esp32 will send um, two measurements. The first one, and I think we will look into it a little bit, but the first one is the distance. So this is the measured distance that we find. And the second one is the battery level. So every so often, it will come and it will give us these 4 bytes, I think. And in BLE, I think the maximum transfer unit, I'm not completely sure about this. I think it is 23. So yeah, this is, let's see if I can, not sure how to remove everything here. I'm gonna just control Z all the way back as far as I can get, I guess. Yeah, so that is the goal of the exercise today. Or at least we're gonna go through the process. Let's see if I can erase everything, because wow, I do not know how to use Microsoft Paint, of course. So let's see if I can do this here. Nope, this doesn't work. Right, let's see if we get a feel. Wow. All right, let's clean that up then. Okay, so let's go over this setup. Okay, so let's see if I can still go through this. So we looked a little bit over the permissions. We needed to do then the post notifications to receive the frequency so often. And then when something is very close, we will both do a vibration and the post notification. Now, here's something that I haven't figured out yet, and is that if I want to get a vibration, um, I need to be with the application on the foreground, which is useless really in the end. But we have to fix this basically. What I'm saying is that if the application is open, if the application is in the foreground, then it will send a notification and it will vibrate. But if the application is in the background, I need to create a service and so on, and I have not figured this out yet. So what I did then is I created a BLE patch, is what I call it. So Bluetooth Low Energy Patch. I call it a patch because the sensor right now is on a 3D printed patch. but it will be wherever. So I have to change this. It will not be a patch soon. Um, and yeah, we have the launcher here, which is default setup. When you create a new project, we get these icons that are yeah, just the default ones. Doesn't really matter too much. So let's go into the source code for what happens here. So the let's see, am I in the right layout? Yeah, not okay. So when the application starts, it calls this onCreate method. This onCreate method uses this set content. This is the default greeting one when you do a hello world. So you can see this is extremely basic. And then there is yeah, this is the default as well when you're creating the preview ones. But it doesn't really matter. This is not being used. What is being used is this part here, and we have a get sample here. This is general attribute something I can't really remember what it is. So um, when we go into the BLE patch theme, we have we're I mean for right now don't care too much about the themes. To be honest, I'm just trying to use a dark theme. The only thing I'm using here is that if something is very close, I want to show text that is in red. If something is not so close, I want to use something purple or green, different colors depending on where it is. So it doesn't really matter too much this part. Um, and then I'm using this sample application on from GitHub where they are explaining what are the things that we need to go through. Use a bunch of decorations for the different permissions that are needed, and there's actually there is a part in the application that is in charge of requesting permissions to the user. So this is I think it's a dependency that asks the user, hey, your application needs to do this and that and so on, which are these permissions. So the user will be greeted with a checkbox style, and we will have to click on them. Um, so I create some sort of a state. The idea is that we will connect to a device. So we will first scan the devices, which is this find devices screen. And then if we find a device that is matching our ESP32 ideas, for example, the names that we are giving, then it will actually allow us to connect to them. I don't want to connect or to show all of them because I think there are many names that at least when I was trying to scan, I get too many things that I do not really care. So the most important part here is that I am looking for a service UUID. So within this get server sample service, which is probably here, I have created this, or I'm using this UUID. So basically, when we look at the raw source code, um, it is going to advertise itself as this ID. I think this is taken from one of the example of the ESP-RS from the Wi-Fi ESP-Wi-Fi repo from Expressive, and they have these examples here. So I am basically using similar ones. I think they are. What's the difference here? I can't remember. There is a difference between these two guys, I think, but I can't remember really. Um, I don't know if this highlights them. No, it does not highlight them. But yeah, there are some differences for different kind of sensors. But because I am only interested in sending two different numbers, basically, or 4 bytes, then it's only one package in the end. So yeah, this is the services UID. This is with ESPRS. There is a little section in which you use some macros to register or to broadcast your device ID, and then some service characteristics UID. So these are pretty much static right now. I think the goal will be that every type of sensor, for example, the TOF camera would always broadcast itself as this. So I will change this to be something like yeah, it will be for TOF, it will be this or maybe this, and then for sound sensor or for light sensor or whatever, we will have a different ID, a different UID. Um, what else is interesting here? This is all taken from the default, so it's gonna be the same thing that we had on GitHub that they're providing. Um, so I decided to add these constants here because yeah, I was I need to use it in a few different types, few different places. I think there is another filter in which I'm saying like if there is a specific word in the name of the device in the string itself, then we will use it. Otherwise, we will think like maybe this is not something we are interested in. So going back here, we scan the UUIDs. We find our UUID, and then yeah, we create these different sensors that we are interested in. So this is the name that actually I was saying that I am saying hey, my ESP32 devices, they identify themselves as seb-patch and something. So this something is, for example, usually it's a C3 or a C6, depending on if it is an ESP32 C6 or C2 or S3 and so on. So they all start with this. And I am only interested in capturing this. I think this will have to change. This probably will become also its own constant. But anyway, we find that the devices must match, must start with this. So in your case, it will be something different, and the service UID that I use are also going to be different, but they have to match what is on the Rust side. And then we will get different data from it. So when we get the list of devices already, which are going to be stored here, we will be able to click on them or to touch the button, and we will connect to a specific sensor. And in this case, I think it is in this sample box where we get we decide to parse it's not here, maybe it's here. Yeah, so this is a little bit, well, this is not a little bit ugly, this is very ugly. It has definitely have to change this properly. I started with only adding one sensor, and little by little, when I added the second sensor, it grew out of proportion, I guess. So definitely we have to change it. So again, we use the same service UUID from before. So this is basically when we have already clicked on the connect to the device. Basically, we have selected from the possible different sensors. And we will make sure that we are connected to the ones that we are interested in. There's too many devices nowadays, so yeah, I didn't want to scroll too much, but As the number of esp32s grows, then also is going to be something interesting. So we get this characteristic, which is the sensor that has the two different um, has the two different values that we care. Um, so first we will initialize the distance sense 10,000, something that is out of range, and then we will get different colors assigned. So we will say by default there's no notification, actually there's no importance. Um, we don't really care about anything because we don't want to share anything. And here we say if something is less than 40 centimeters or 400 millimeters, then we want to have a color red notification with an importance high and a color scheme of error. The text size, I think it changes, but I can see it here. So this logic is duplicated from the same logic within the ESPRS, and this is something that I was thinking that maybe from the Rust side we can generate a WASM file that contains this logic, and then translate this because it's going to change. For example, as I was saying, I have the two sensors. One is for 4 meters, one is for 2 meters. So maybe we will say, let's use, if I change this number because the distance is going to be for 4 meters, now I have to code both in Rust and in Java, Kotlin. So maybe this can be part of the WASM deliverable. That's going to be for the next level probably. So yeah, if 400, then we want to send a notification that is of high importance and that vibrates. If it is less than 800, then it's not really that important. Importance low and importance minimum. So this is the importance here where we create this channel, this notification channel, and this notification channel will allow us to use lights, use vibrations. There are vibration patterns, but I couldn't really understand how it works. Apparently, there are different frequencies, not frequencies. I guess it's the frequency which it vibrates that signifies different things. So it could be something that is urgent or something that is maybe just a notification that is happens just once, like for example, you get a message, you get just one notification. But if something is urgent, like a call or an alarm, then you want it to be constantly firing. And apparently, depending on this, on how important something is, you can create different things. And to us, maybe it's intuitive what it means. So yeah, if the distance sense is more than 0, so maybe we didn't read anything, so it can also be 0, or actually I don't think it can be negative. Maybe I'm creating something wrong here when I parse the U16. But sure, if it is less than 800, then I am interested in sending a notification. And then I use the notification channel and I create an icon here, which is again from the defaults. And I say, this is the distance that was measured and something is too close. And so it vibrates. If the object is very far, I don't want to send any notifications and I want to cancel anything that was supposed to go there. And then we also create within the window of the application, we create a little table that tells us, for example, what are the services that we have, what is the current distance that is sensed, and then depending on the distance, we will have a different color. So something will be red when it's something that is very close, and something will be just normal when something is pretty far. So as I was saying before, I'm using a dark theme. I didn't know how to use different themes, so basically, this is kind of tied to the current theme And then I have a reading on an A2 pin. This is very hard coded because it has too much what we have on the side of Rust, and it should tell us the current use voltage of the battery, so we would be able to monitor it. And then there is a way to, yeah, get into use. Ideally, I want to be able to write data also to the ESP, but if it reboots, then I lose the data. But yeah, this is basically the current setup. I think I'll post the link to the GitHub repo soon. I couldn't find a tutorial for this, so it's just reading or sending a notification from the esp32 and capturing it from the side of Android application. For setting up the application and so on, I use pairing with Wi-Fi. So basically, I connect my phone. I have to grant permissions to scan a code here, but I'm not going to go through these steps because I'm not really familiar with them anyway. But there's plenty of videos about that. So let's see if we can find the Codium setup, the VS Code setup for this. Yeah. I'm trying to open up now the directory where I was working on this before. Let's see, where did I have this file? Open folder. I'm gonna go over this. esp32. Okay, let's see if we can increase the size of stretch the screen. Okay, so this is using the source code of the ESPRS. Of course, I need to download this. ESP Wi-Fi. Yeah, let's go over this over the so this is the repository from Espressive itself, esprs/ESP Wi-Fi, and in here there is an ESP Wi-Fi subdirectory, and inside of it there are some examples. So first, let's look at how or what are the things that I have changed that I needed to match on Android side. So before this used to be called like this. So what I'm saying here is if I am building for a C3, then I want to something that starts with this is what will be broadcasted. So I'm changing this because I'm working on a new project, but basically this has to be patched everywhere here. And what I'm saying here is that if I build for any different chip, it will still build, it will still be found on Android side. So yeah, this is one of the first changes, and this is within the root repo on example utils. By default, this setting is I think it's just this esp32, c3, and so on. But because there are so many ESP30, or maybe there can be so many for many different purposes, I didn't want to use them like that. So every project would have a different one of this setup. I'm still trying to understand or how to trying to think on how this can actually be reusable better. I have a few ideas, but I still have not explored them properly. But yeah, going back to the examples. Let's see. I think in here was yeah. Was the previous setup, which is kind of like this. Because I was only building for ESP32 C3, but then in this version I am trying to build for many more. So let's look at oh yeah. But so I used as a reference I used the Embassy BLE. So Embassy BLE probably the ESP. No, I think I use this one. So what this one does is that it allows you to use embedded asynchronous, which is like Tokyo but for embedded devices, and you can use asynchronous calls. And then there is a few flags that we have to enable for this, which are basically the coexist one, because we're going to be reading and receiving over ESP, and also the ESPs. Well, the coexist is basically because I will also use Wi-Fi one and or ESP now between the ESP32, so they can communicate between them, send the sensors, and then send over to yeah to the phone. So I can connect to any ESP32, and it will tell me, hey, around me there are these many ESP32s. They have these sensor values and so on. So this is the sense range. This is very similar to what we saw on the Java side. So we have very near, far, none, and off. I also use the smartlets, and depending on how close something is, I have something that would translate into a color. Um, and then, as you can see here, this is an example of why it shouldn't be separated. Because I think in Java side I had 400 and here is 200. So this is why I want to create a WASM file and match them both. But what I'm saying here is that if I read a distance, I want to translate this into a range. And in this range, I'm saying that, yeah, something is very near. And then, yeah, if something is between this range, it's going to be a difference on. And then I create the frequency at which we are going to send a notification of how close something is. If something is very near, less than 20 centimeters, then every 2 seconds we're going to send a notification. If it is something that is not that close, then it's going to be 4 seconds, far, and so on. The sensor can be off. For example, the sensor may be disconnected. We may not be able to I don't know, maybe it's physically disconnected. Or we had a problem with the I2C driver, or yeah, it is just misbehaving. We couldn't initialize it, so we also want to send this. This is different to none, because none means that something is out of range. So something is beyond the useful range of the time of flight sensor. So the time of flight sensor usually it's useful up until 2 meters. Above 2 meters, it will return this value, which is basically saying, "Hey, I couldn't get anything." So yeah, there can be something up beyond 2 meters. Um, but this is what I mean by none, when something is simply not collected. And off would mean actually the time of flight sensor is disconnected. I could not initialize it, and maybe it needs somebody to check the pins. So let's look at um, some of the GAT in the UUID setups that we were talking about on the side of Java. So this is a boilerplate of things that may not be completely relevant to us right now. But basically, yeah, if we go over it real quick, it would be we initialize a logger. This logger is kind of messy apparently for esp32 because it requires, yeah, apparently it has to go and stop something on the side of the processor itself, like an interrupt. So it might not be very good for asynchronous code. But anyway, we need a clock because we need to send notification every so often. We are supporting both extends and RISC-V on this side. It has to be using a little bit different things. And this is the code itself for the Wi-Fi. We are going to use I/O to be able to get the pins, for example, for the LEDs. And then we will also measure the battery. So in this case, for example, I need to have the analog to digital converter. It's going to be pulling from here, from this specific pin. One thing that I really like from the Rust version is that once I take a pin, for example, GPIO1, then I cannot reuse it, which it makes complete sense because I am not really. You cannot have two pins that are connected to different sensors, I guess, unless you decide to see somehow. But that is what this module would do. It says, yeah, let's probably this is SDA and CL. But we will try to find or try to initialize the sensor that we have here. And then we will use every 20 milliseconds, we are going to capture data from it. There's a button that I'm not using. This comes from the default source code. We are going to be using, yeah, the timers here. Some more boilerplate. In this case, I'm saying, hey, you know, I have a connector which is for BLE. I have an X-Blink loop, and these are all rev cells because I need to move into the Bluetooth, sorry, into the asynchronous code. So the reference have to be sent over. We will do borrow mutes to interact with them and so on. So this is the main loop, and in here is where all the magic starts. We create. Where is my, yeah, so this is basically the one of the main parts here where we say, hey, I'm going to register my service as this UUID, and this has to match what we have on Java. I'm going to give it a name. The name we are not using in Java, it doesn't matter. And then here is saying, hey, if somebody's interested in reading this characteristic, which is this UUID, then there is a read function and there is a write function and there is a notify as well. So this read is when I go into the application and I click on the read, and then I get one time a notification. The write, which we are not using, is when we want to send something from the phone. Probably we can say something like, you know, alter range or change name, or not sure yet how it will be. Probably I will use it to synchronize the NTP somehow, like a fake NTP, where the phone will broadcast to everybody. So when a ESP32 boots, it will say, I have no clock. Please tell me what is the current date, and then it will get the the date from other ESP32s or from a phone or from a computer that is connected or that is on. I still cannot this working with a computer, by the way. Not sure what I'm missing. Okay, so we are going to use this notifier. Um, Basically, what this loop, let's go to the end 1 second. This loop, what it does is that it creates a notifier as an asynchronous closure and awaits for it, and then the loop goes back to the start. So this is the main loop. So basically, every time it loops, it's going to say, these are the, it's going to initialize everything. Maybe this shouldn't be here. Maybe it should be outside, but I'm not really sure yet. So anyway, this is the asynchronous call that we get here from the notifier that has to return a notifier. So the last part of this call, of this asynchronous function is going to be this. We're just going to say, you know what? If, or actually not if, we're going to just broadcast the distance over this distant handle, and this is data. So the data here is what I was referring, that we have 4 bytes. The first 2 bytes are the distance, and the second 2 bytes are the measurement of the battery. I show here, for example, that I have a notification for this case. So I also use the next blink loop inside this asynchronous call, and I also have a slip here. So maybe this is not the best place to do this, but what I wanted to show here is that we can also use the esp32 to show the distance. In this case, it will show it not in a display, but with the LEDs. So with the LEDs, it will say, yeah, let's transform this distance to a color, like we saw before, that there is a way to transform from distance into a sense range and also into color. So we can say, if we receive something in here, we become very near, and then this very near can become into a dark red, and then a NeoPixel can get this value, can send this value, or get this color, I guess. I also have this print line, which apparently these prints are very heavy, so I need to remove them at some point. But the main part here is that we will use this handle for sending the distance, and this distance handle is, why can I not find it? For some reason I cannot find this. Maybe my search is off. Oh yeah, this was tricky for me. So we create this characteristic, and then this is a macro, and it appends underscore handle to these names, and apparently this has to match. If we I tried this before, or I got a strange error when I tried to do this without, or maybe I wasn't careful enough. I didn't read the documentation, of course, so it was my fault, but it was tricky for me to see that, oh yeah, I need to be calling it like this. So what else can we look into here? I think this is pretty much it. Yeah, this is it. If we wanted to receive or something from if we want to receive something from the cell phone into the ESP32, it will be receiving this closure. We could also do it inside somewhere else. For example, below we can do this. This is the RF distance is the closure that we would execute when the user clicks to just see one time the distance. So this is a different to the notify one, because this is saying, give me one time the distance. This one is more like, I'm going to bind to the ESP32, give me over and over and over the distance. So yeah, this is how we will interact with it. Basically, we borrow mutably the time of flight sensor. We get the distance from it, Then we send it over in this byte slice. This will be 4 bytes because this is what the application expects. Um, so yeah, this 4 is probably should be a constant somehow. This I have to split this into multiple places, and this is copy paste basically is what happens on the side of the notifier function that is constantly broadcasting. So this is basically this part here where we say, hey, the first part of the asynchronous function is, yeah, let's wait 100 seconds, 100 seconds, 100 milliseconds. Let's borrow mutably the time of flight sensor because this is inside ref cell. We read the millimeters and we say, yeah, if we get a distance, we're going to send over a distance here. If anything here fails, we're going to return the U16 max. And again, because this is a U16, we can translate this into our ranges. So this is something that I don't know if this is the best way to do this, but basically I keep track of the last sense range, and only if the sense range changes would I consider changing the next blink loop. The next blink loop is also the next notification loop. Is I need to rename this variable, and only when the next blink loop is 0, we will yeah blink our LEDs, or maybe we will beep. And if it was a buzzer, yeah, we will buzz. If it is a vibration model, we will vibrate and so on. So yeah, this is basically it. We wait, in this case, 400 milliseconds, and then we stop the blinking. So we blink for 400 milliseconds, then we send a notification, and we come back to this part. So basically, because we have 100 milliseconds here and 400 milliseconds here, we are sending a notification or processing, sending a notification every half a second. This may be, actually, I'm not sure if this is too often or not. No, actually, this is not true. What we're doing is every half a second we are measuring, but only when there is a blink loop, which is this next blink loop. Only when this is when it is required, we will notify. So basically, even if we look at the next blink loop, which is the number of this is the number in, this is not, returns the number in, this should be seconds. So for example, we will have measured 4 times in 2 seconds, and we will send a notification only once, even though we have 4 measurements, if we are not changing in this range. But if we are in this range, for example, imagine that we read something far. The next measurement, which happens in the next half a second, is actually very close. Imagine that there is something that moved very close to us very fast. We will send a notification immediately, because in this case we're saying, hey, there is something very close. We will send a notification right now because we are changing from far to very near, and also the notification will change to every 2 seconds. The first time that I did this, I was waiting until the 6 seconds finished, and by 6 seconds I have already been hit in the head, so it wasn't very useful. So yeah, this is it. I will post some links probably, if I remember. But I also need to split this a little bit and push the code for the Android version. All right, that's it. Bye bye.